get ready. I think 2 more minutes. Yes, everyone? Yes? Please let me know when it's 10. How's everybody with Biochem? Big exam, Biochem, 31 questions. So please be mindful. It will account to a lot of percentage to your grades when it comes to biochemistry and genetics. I think this is the only exam with the maximum questions. So just like exam one, you all did great. Please let this be a good exam too, so you're safe, right? I think, if I'm not wrong, this is the exam with respect to biochemistry, this is the module exam with the highest exam questions. Yes? Right? Everyone? Yes, please be mindful of that. And it will be great if you can hit this high too, just like exam one. You all can do it. 2 more minutes. Please see that I don't want 10 to 15 recordings floating. So that's why the mini recap Sunday before the exam, that will be recorded. That will be recorded, please, so you can do a last minute touch up before you go into the exam. Does that make sense? I think these sessions are for you to ask questions, actually, right? If I record them, when would you ask questions? Does that make sense? But yeah, the last recap will definitely be recorded. Please, a minute left, am I right? Is everybody good? Can you hear me? Can you see the slide? I'm sorry, I was having a little problem with my internet, so I hope everything is good. Yes, great. Okay, let me know when it's 10. Good morning, good morning. I hope everybody's good. How many courses you have this exam? I thought you don't have physio, right? 3? Physio is not there, that I'm sure, right? No physio. That's a good thing. 3, oh, 3 is not bad. Oh, great. Concentrate on biochem. Anatomy, histobiochem. Not bad, not bad. Is it 10? Okay, great. I think it's 10. Everyone is ready? Yes. You can hear me. You can see well, right? No problem? Are you seeing my slides? Everyone? Great. Please see that as I tell you, you can see my first PowerPoint. Though there are 6 to 12 lecture, every lecture will be equally tested. You have one more short lecture, but I would say about 5 questions per lecture. Include them together because the NADPH2 is part of HMP shunt, maybe more than 5 here, but otherwise 5 questions per lecture if you treat them together. Remember, there are 31 questions. You know, CV is there in your interactive session. Please see that these are my exam help. I'm going to post this with the PowerPoint today, so you can join as you wish to. Sunday I would do gluconeogenesis and glycogen recap. Please see, I'm starting an early exam review because remember, there are 31 questions. That is the highest in the module so far. So I want you to be careful and do your best. And I'll give you all the support to make you successful. So your exam reviews will start. Monday would be 1, Tuesday would be 2, and Friday will be 3. Please see that where is the help, all the pre and post discussion files. Please look into them. There are discussion files. I've also posted for monosaccharides. Then you, under the exam folder, you will all have all the help files. Also, please, Dr. Nick from Harlem has some support files, but please, they are optional help, and I'm not reviewing them. Anything that comes from Harlem goes under that. So it's up to you if you want to refer them. Please stick to your learning objectives. I encourage you to watch Dr. Binstock's lecture. What I'm going to do today is sail you through what are the important key points you should know when it comes to testing glycolysis and TCA. Please, first of all, know is what pathway. So what is glycolysis? High insulin or low insulin? Is it a well-fed state pathway or a low insulin pathway? Glycolysis. Well-fed, first of all, state. You know well-fed is high insulin state. So in well-fed state, how do you maintain glucose? You go to bake sales. So should you know your sources and should you know your carb you consume and sources? Yes. For example, this will help you in the coming week lectures also. For example, if you have a galactose metabolism defect, will you restrict lactose or sucrose if there is a galactose metabolism defect? Why should you know sources if there's a galactose metabolism defect? What would you restrict, lactose or sucrose? Lactose or sucrose? Anyone? Lactose. So you should know what are your sources, lactose, milk, sucrose, table sugar, and also what they are made up of. Also get used to this. Monosaccharides are the best reducing sugar, only absorbable form, because you might, for this foundation exam too, you should get used to test positive for reducing sugar, but negative for glucose. When test is positive for reducing sugar and negative for glucose, what are you thinking? What is in the urine? Test positive for reducing sugar, but negative for glucose. This is some finding that adds on in foundation too. So what is in the urine? If the test is positive for reducing sugar, but negative for glucose, that means it is either, anyone? Galactose or fructose. Please see that do these four differentials there for sure. We will do this in the coming week also. So I told you sources are important. Only absorbable form is monosaccharide. Your predominant sugar is which one? Glucose. So should you be aware of the transporters that pick them up in the peripheral tissue, which is here? Yes. Predominant sugar after meals in well-fed state is glucose. And what is the sequence? Who has the proportional flow? After meal, what flows in? Where would the glucose flow in? Which transporters? Which have a proportional flow? GLUT2, and pancreas will release insulin. Now, what's in pancreas that releases insulin? What is in the pancreas enzyme that releases insulin? What is the enzyme in the pancreas that helps in releasing insulin? Glucokinase. Now see, here comes your regulation. Bring it from foundation 1 to foundation 2. Also with what Dr. Binstock has explained. Now, did you learn that glucokinase is under glucose control and active when? After meal or fasting? After meals or during fasting? When is glucokinase active? When? After meal. Also, so this is, please try to distinguish in this exam what is my primary regulation and what is secondary regulation. Now, someone asked me that Dr. Binstock has also explained the role of fructose 6-phosphate. That is secondary, but primary is that glucokinase is under glucose concentration and active after meal. Then you get fructose 6-phosphate, right? Not immediately. So know your primary and then secondary. Yes, when fructose 6-phosphate is high, will it try to release glucokinase or push it back into the nucleus? If fructose 6-phosphate is high in the cells, will it release glucokinase or push it back into the nucleus? Anyone? Fructose 6-phosphate is high. What will it do to glucokinase? Push it? Yes? No, when not release, back into nucleus. When is it released? So that's why distinguish primary and secondary. Primary is that after meals, glucokinase should be active and released. Once you have done metabolism, turn on oxidation, and fructose 6-phosphate is high, it should go back to the nucleus. Remember that fructose 6-phosphate high means you have enough of glycolysis, right? Why do you need glucokinase? So yes, understand secondary regulation, but not forget the primary. 1 and 3, they are not, they are constant flow, please, constant kinetic, irrespective of insulin. But once pancreas release insulin, where is GLUT4 expressed? And insulin starts its action of what? Where is GLUT4 expressed? Where are GLUT4 expressed by insulin? In Where is how is insulin is expressing GLUT4, but where? Which tissues? Adipose and skeletal muscle and adipose tissue. So that's what insulin function starts. Insulin function is to push glucose from circulation inside the tissue, but only and the only one is insulin mediated is GLUT4. But insulin does have the effect to turn on oxidation in all the tissue, irrespective of transporters, different kinetics. Two, proportional flow. One and three. One and three. So you need to know your transporters on the tissue. One and three. What flow? Constant. And insulin mediated, GLUT4. But now, yes, insulin is released by pancreas, you're in a well-fed state. I will distinguish this, which students tend to forget, that well-fed state is not just high insulin state. After a while, when oxidations have turned on, pathways have turned on, which oxidation pathway we are learning today? Because I'm only doing two. Which oxidation pathway are we learning today? Because I'm only doing two oxidation pathway, and that is for energy. Which are we learning today? Yes, anyone? What pathway? Glycolysis and TCA. So this is insulin function to push glucose from circulation to tissue, turn on oxidation. Glycolysis is only for carb, and TCA is common to carbohydrate, lipid, and protein. But after these pathways are turned on, now body will eventually go into high insulin and high ATP state. Then there's a switch. When you have enough of ATP, what does body switch to? Spare glucose oxidation and do what? Spare glucose oxidation and do finally what? Storage. So how is glucose stored? That will come on Sunday. Glucose is stored as anyone? How is glucose stored? In a high insulin, high ATP state as glycogen. Where is glycogen? Liver, muscle, or both? Liver, muscle, or both? Both. We will do that on Sunday. So yes, this is the function of insulin. First, push the glucose inside the tissue, especially only GLUT4 because they are insulin mediated, but turn on oxidation in all the tissue, which are your pathway, glycolysis for carb, TCA common. And when you get enough of ATP, glucose should be spared from oxidation. And what will body switch into? Anabolism. Here I will discuss that PFK2 regulation. PFK2 regulation kicks in only in the liver when you are in a high insulin, high ATP state. PFK2 is not an enzyme for glycolysis and kicks in that state. I will explain that. Also, mechanism. If well-fed state is a high insulin state, how does insulin work? Does insulin increase? There are two different things. Does insulin increase or decrease cyclic AMP inside your cell? Does insulin increase or decrease cyclic AMP? Decrease. And is insulin always dephosphorylating the key enzyme? Yes. Don't memorize if they will be active or inactive, which will form in which form? Any pathway or any enzyme which is supported by insulin should be active in which form? Any enzyme supported by insulin should be active in which form? Dephosphorylated form. Period. Don't have to memorize. Let's do 1 and 2. Are they well-fed state pathway? 1 and 2 are the well-fed state steps. 1 and 2, which we are doing today, glycolysis versus TCA cycle. This is the summary, and you can go back to Dr. Binstock's slides and refer those slides, but it's a high insulin pathway. Please, students make this mistake, whether aerobic or anaerobic glycolysis, they both are cytosolic. They are not mitochondrial. But what is mitochondrial in that? The NADH produced in glycolysis need mitochondria. So they need mitochondria, but the steps are all glycolysis, aerobic or anaerobic, is cytosolic. Secondly, why we discuss carbohydrate metabolism, especially for brain and RBC. RBC entirely dependent on glucose. That's why. Remember pyruvate kinase deficiency? Can RBC function? Pyruvate kinase deficiency, can RBC function? Can they function if there is a pyruvate kinase deficiency? Can they do that? Like, no, that's why pyruvate kinase deficiency leads to hemolytic anemia. Brain. Do you remember chronic alcoholics thiamine deficiency? If there's a thiamine deficiency, can they use PDH and energy yielding reactions in the brain, chronic alcoholics? Can they do PDH? Chronic alcoholics have thiamine deficiency. Can in chronic alcoholics with PDH be functional enough to do energy yielding reactions in the brain? Yes or no? In thiamine deficiency. PDH, will it be functional? Highly functional? No, and that leads to the brain neurological signs and symptoms because of these two needs. Also, please know the rate limiting enzyme, connect the right enzyme to the right pathway, then only you will know in what state it will be active. So are they all well-fed state enzyme? Yes. I'll tell you why there's a difference in energetic, aerobic versus anaerobic, but this is key, please. There are only one primary player. So tell me primary player for turning on glycolysis is high ATP or high NADH? What is the primary player to turn on glycolysis? High ATP or high NADH? High ATP or high NADH? Anyone? What's the primary play? High ATP, not NADH, please. No. NADH is the primary regulator for TCA cycle, not ATP. Is that clear, everyone? Everyone is good with that? So I've mentioned here. Did I mention NADH here as activator or inhibitor? Have I mentioned NADH here? Yes? Yes or no? No. ATP to ADP ratio. High ATP will slow down or activate glycolysis. High ATP will slow down or activate glycolysis. High ATP. High ATP is going to slow it down. None of the pathways shut down. Yes, definitely bring fructose 2,6-bisphosphate and citrate. Fructose 2,6-bisphosphate turns on glycolysis or gluconeogenesis. Fructose 2,6-bisphosphate activates glycolysis or gluconeogenesis glycolysis. Citrate is a positive or negative effector for glycolysis. Citrate is negative. Why citrate is negative? I will show you. But have you done these two deficiency? Are we going to do both in glycolysis, pyruvate kinase deficiency, and lactic acidosis? Please do not forget to link your pathway with regulation, rate limiting enzyme concepts, because you're not tested on any memorization of the pathway and clinically. Now, you know aerobic versus anaerobic. Where do you do lactate formation, aerobic or anaerobic? Where do you do lactate formation, aerobic or anaerobic? Lactate formation is in anaerobic. Why? Because you don't have electron transport chain to regenerate NAD, because you don't have enough oxygen. So also you should know two concepts, that forming ATP through ETC is known as forming ATP through ETC. Is it oxidative or substrate level phosphorylation? It's oxidative phosphorylation. Secondly, for this step to happen, you should have functional mitochondria and enough of what? For this to happen, that oxidative phosphorylation, enough mitochondria and enough oxygen. Is oxygen enough here? Is oxygen enough here in anaerobic condition? No, that's why you need to form lactate to regenerate NAD. Please know this reaction well. It's clinically relevant, physiologically relevant. What does the enzyme tell me? Pyruvate lactate, and it's reversible normally in your body. What's the enzyme here? What is the enzyme here working here, this step? Can you name the enzyme which is catalyzing the reversible reaction? Anyone? Pyruvate lactate conversion? What's the enzyme? Not PDH. You got to mindful lactate dehydrogenase. Absolutely wonderful. Also, where is lactate formation physiologically? Naturally, RBC, they lack mitochondria. Skeletal muscle, not enough of oxygen. Cardiac muscles, are they adapted to aerobic or anaerobic glycolysis? Cardiac muscles, are they adapted to aerobic or anaerobic glycolysis? Cardiac muscles. Cardiac muscles. Skeletal muscle is anaerobic. Aerobic, that's why myocardial infarction leads to lactic acidosis. So there is a physiological relationship too when it comes to lactate. You know, I told you draw the outline, but please know only certain steps. Drawing outline of glycolysis and TCA is actually good. First step, ATP is consumed. First phase, sorry. First phase, ATP is consumed. Second phase, ATP is produced. Now, 1, 2, and 3. Which one is oxidative phosphorylation? 1, 2, or 3? So knowing the concept and then applying it, not memorizing number of ATP. We will not test you on how many ATP are produced in aerobic, how many in anaerobic. The problem is you got to understand why. So 1, 2, or 3, which step is oxidative phosphorylation? 1. And this step will be missing in aerobic, or this step will be missing giving ATP in aerobic or anaerobic glycolysis. This step will be missing ATP anaerobic glycolysis. So you also need to understand for this step, this first of all, this is a step of oxidative phosphorylation. Wherever NADH, FADH2 are produced, here FADH2 is not produced, but NADH is. They will go to electron transport chain to produce ATP. That is known as oxidative phosphorylation. You cannot do this step if the mitochondria are not functional or oxygen is not enough. Substrate level phosphorylation or cytosolic process can occur if the mitochondria is not functional or if there's not enough oxygen. Does that make sense? Also, then you can count energetics. If anaerobic glycolysis is missing this step producing ATP. Now, please see that. Please understand, students make this mistake. In anaerobic glycolysis, it's not that this step is not happening. NADH is produced in anaerobic glycolysis, but it will not be able to form ATP. So this step will miss only giving ATP, but this step will still happen in anaerobic glycolysis. So if this step is missing, how many ATP, net ATP? 4 minus 2. That's why only there are 2 net gain in anaerobic glycolysis. Understanding the concept of oxidative versus substrate phosphorylation. Though I have mentioned you, make an outline, but let's talk about only steps that are clinically and physiologically important. First step, hexokinase, glucokinase. Absolutely, I'll tell you the regulation. Second step, highly regulated. Am I going right? Sorry. Yes. Okay, sorry. First step, that you are producing. When you are producing lactate, you are regenerating NAD. You are not producing NADH. When you are forming lactate from pyruvate, the purpose is to regenerate NAD. So know the arrow too. Great. Sorry, I'll repeat again. First step important, hexokinase and glucokinase. I'll tell you the regulation. Third step, PFK1. Highly regulated, highly allosterically regulated. Each enzyme is subjected to different regulation. Important. Dehydrogenase, this one, is linked to oxidative phosphorylation. Although it's not very important, but I'll still tell you that this step is related to substrate level phosphorylation, though not regulated, but I'll tell you the importance. Again, hexokinase, glucokinase, important regulation. PFK1, highly regulated. Dehydrogenase, you're seeing my cursor, oxidative phosphorylation. This step, substrate level phosphorylation. Pyruvate kinase, also rate limiting. So you know the rate limiting step, hexokinase, glucokinase. Can you complete the list? Can you complete the list of rate limiting steps? So you put the right enzyme in the right pathway. When they test you in the enzyme, go to the pathway. So can you give me the enzymes for glycolysis, rate limiting? Anyone? One is hexokinase, glucokinase. Can you complete the list? Hexokinase, glucokinase. What else? Anyone? PFK1, absolutely wonderful. And the last one is pyruvate kinase. Now they are each subjected to regulation. Know first the primary regulation. Glucokinase is active after meals. Yes, not fasting, under substrate concentration. Yes, if you want to do Dr. Binstock fructose 6-phosphate effect, please do. That is secondary. First, glucokinase is under glucose concentration. Hexokinase, product inhibition. What's the product of hexokinase? What is the product of hexokinase? They're saying product inhibition, but what's the product of hexokinase? Glucose 6-phosphate. Now, this fructose 6-phosphate, 1,6, 2,6, glucose 6, they all look the same. Please repeat them to know what is the product. It's glucose 6. Very good, very good. PFK1, highly regulated. Now, you don't need to memorize the negative modifier. Give me one common negative modifier of PFK1. One negative modifier of PFK1. High What should come to your mind first? What will PFK1 will ATP? Absolutely wonderful. You can add citrate. You can add citrate. Any positive modifier of PFK1? You can add citrate, why not? But first thing should come to your mind is ATP because primarily controller of glycolysis is ATP. Please know that, not NADH. Though NADH is a reflection of ATP, NADH is TCA. So tell me one positive for PFK1. AMP, very good. What else? One more. Fructose 2,6-bisphosphate. Pyruvate kinase, will it be active in phosphorylated or dephosphorylated state? When you want to assess that, no, is this enzyme supported by insulin? Is pyruvate kinase supported by insulin? Is pyruvate kinase supported by insulin? When they test you in the enzyme related to the pathway, yes. So it will be active in dephosphorylated state. So let's see, why do you need this extra PFK2 when you already have a PFK1, good regulation, all the rate limiting enzymes are regulated? Please know that. I'll just explain you. Please don't Google around this concept. If you can understand from how I'm saying, we'll do exam review. I will answer your questions too. When you are in a high insulin and high ATP state, do you want to switch to anabolism? Do you want to switch to anabolism when you are in a high insulin and high ATP state? Yes, but the problem is the ATP is still high. The intermediates of glycolysis and TCA are involved in anabolism. But when ATP is high, will glycolysis and TCA should slow down in most of the tissues? Should glycolysis? Yes, but that's a problem for anabolism because intermediates of glycolysis and TCA are involved in anabolism. So then only in liver, please, not in most peripheral tissue. When ATP is high, insulin kicks in to overcome ATP inhibition, and fructose 2,6-bisphosphate then turns on glycolysis and TCA for a little while, only in the liver. That's why you need this extra insulin PFK2 regulation. Do you understand that? If you don't, I can explain you again at the end of the session. But insulin PFK2 regulation only kicks in the liver, mainly, primarily, when you are in a high insulin, high ATP state. So you also need to understand when you are in a high insulin and high ATP state, body wants to switch to anabolism also. That's why if you might have learned from Dr. Binstock that TCA is catabolic, anabolic, or amphibolic. TCA is catabolic, anabolic, or amphibolic? TCA cycle. Anyone? Is it also involved in synthesis? Both. So understand that intermediates of glycolysis and TCA itself are involved in anabolism. And anabolism happens when you're in a high insulin and high ATP state. But till now, there are two cytosolic, you know that. Keep them in the right compartment, please. Because if mitochondria is not functional, will lactate formation happen? If mitochondria is not functional, can lactate formation happen? Yes or no? If yes, because remember they are cytosolic process. So you need to understand which steps are cytosolic and which are mitochondrial. I have not introduced this year. I'll come to TCA cycle, but please pay attention on pyruvate lactate conversion and when can it happen physiologically, altered physiology and pathology. Look at this. When two alcoholics have a high ratio of NADH to NAD. So do connect pyruvate kinase deficiency clinically and alcoholics to glycolysis. So do alcoholics have a high ratio of NADH to NAD? Yes, do they have? High ratio of NADH because they do alcohol metabolism. NADH accumulates in them. So do alcoholics have a high ratio of NADH to NAD? Anyone? Yes. And that is why this reaction in them, which is reversible actually in your body, keeps moving forward. So what do alcoholics suffer from? What pathology? They will suffer from if this reaction is moving forward and forward, not going backward, lactic acidosis. Also, when they are not going backward, what they can synthesize, what is this pathway? Lactate going back to form what? Lactate going back, which will be Sunday. When lactate is going back, what is the purpose? No, lactate going back. First, give me normal to understand normal. This lactate goes back to give you what? What's the final product? Reutilize, exactly, glucose. I like that answer. So that is why alcoholics have lactic acidosis and hypoglycemia. Also, please know that alcohol, especially this product, formaldehyde from methanol, acetaldehyde is very toxic and they cause toxic effects, which Dr. Binstock has mentioned. Please do them. I'm bringing your focus to the topics. I encourage you to go and look at Dr. Binstock's slide. I'm always professional. I encourage you to watch slide, but my line diagrams help you bring focus. You know that disulfiram, which is alcohol anti-abuse drug, is based on the same fact that as acetaldehyde accumulates and then they get aversion to alcohol. So this acetaldehyde and formaldehyde, acetaldehyde from ethanol and formaldehyde from methanol are toxic. Dr. Binstock has explained their toxic effect. Don't forget to do enzyme deficiency, right? So is pyruvate kinase deficiency this step? Is pyruvate kinase deficiency this step? Yes. Do you pyruvate? What is enzyme deficiency theory? Whenever there is a block, intermediates above the block accumulate or low? Intermediates above the block accumulate. Intermediates behind the block, intermediates behind the block, low, or product is low. Please, all your answers of signs and symptoms are around the step. Also, please know when intermediates above the block accumulate, they follow alternate pathway, which may be minor in your body and will become major. So if I tell you low pyruvate and high phosphoglycerate intermediates, what is your answer? Which enzyme deficiency? Low pyruvate and high phosphoglycerate intermediates. Yes, pyruvate kinase deficiency. Also primary presentation. In pyruvate kinase deficiency, hemolytic anemia is because of low ATP or oxidative stress. Low ATP leads to hemolytic anemia or oxidative stress. Low ATP. That's why later on we will do this differential. Please, if you want to do well in foundation 2, take the common presentation and do differential. Right now, hemolytic anemia, you will see back again, not just pyruvate kinase deficiency. Cause is different. Hypoglycemia, you will see a lot of time. Decreased exercise tolerance, a lot of time. Lactic acidosis, a lot of time. Make the common symptom and do the differential. Let's do TCA. Please stick to your learning objective. Watch Dr. Binstock's slide. I'm telling you the focus. We did glycolysis only for carb, but remember, TCA cycle is common for carbohydrate, lipid, and protein. Pyruvate is formed where? Cytosol or mitochondria? Where is pyruvate formed? Cytosol or mitochondria? Pyruvate. Where is pyruvate formed? Cytosol. It has to be pushed into the mitochondria to start TCA cycle. Please don't make that mistake. Pyruvate is not the starting molecule for TCA cycle. Who's the starting molecule for TCA cycle? Who's the starting molecule for TCA cycle? Acetyl-CoA. Wonderful. So that is why how many, and also only aerobic oxidation goes into TCA cycle. How many ATP in aerobic? 2 or 8? How many ATP in aerobic? 2 or 8? Aerobic glycolysis. How many? 8. PDH? PDH? There will always be 2, 2. PDH. How many in PDH? PDH step. 6. 8 plus 6. 8 plus 6. 8, 14. How many in TCA cycle? Make it 2. 1 acetyl-CoA 12. 2. So 6 plus 24 plus 14. 6 plus 4. Sorry. 8 plus 6 plus 24 is how much? 8 aerobic, 6 PDH step plus 24 TCA is how much? Or how many, sorry. 8 aerobic, 6 PDH and 24 TCA total 38. I'll tell you when it is 36. Okay, do you understand that? 8 aerobic, 6 PDH step and 24 TCA makes it 38. Also, TCA cycle is amphibolic. Now let's bring the 2 cytosolic and 2 mitochondrial fate. Why? Because you did aerobic glycolysis. Only aerobic goes into TCA cycle, pyruvate is moved in. And also know that 3 or 4 steps. So first 2 cytosolic, 3, 4 mitochondrial. Please don't flip-flop them. Now 3-step or 4-step, which one will lead to TCA cycle? 3rd step or 4th step? Which 4th step? So 4th step, please know, is active over 3 in well-fed state. Whereas 3 steps will lead to, so 4 step will lead to TCA cycle. 3 step will lead to which pathway? 3 step will lead to which pathway? Anyone? Step 3 will lead to which pathway? Gluconeogenesis. That's why 3 step is gluconeogenesis well-fed or low insulin? Gluconeogenesis is well-fed or low insulin? No, low insulin. So 3 step is more over 4 in a low insulin state, but none of the steps are shut down. So since we are doing glycolysis followed by TCA, 4 is active over 3. But the starting molecule for TCA cycle is acetyl-CoA. So do you understand this crossroad? And that's why I did 8 from aerobic, 6 from PDH, and 24 from TCA. So let's start TCA cycle. Starting molecule is what? Starting molecule for TCA is what? Pyruvate or acetyl-CoA? Pyruvate or acetyl-CoA? Starting molecule, acetyl-CoA. Pyruvate moved in, but you need to know the crossroad. But also, please, because I'm doing a quick recap. Now, you form pyruvate in the cytosol by aerobic glycolysis. Yes. Did pyruvate move into the mitochondria? Yes. What comes first then? What comes next then? So you can start the TCA cycle. What comes at step 4? Yes, I just want to bring that too. What comes in just a minute? I want to bring that too. What comes at step 4 to start the TCA cycle? Very good, PDH. Please do it some multi-enzyme, multiple vitamin enzyme. What are the multiple vitamin? Thiamine, lipoic acid, coenzyme A, FAD or NAD. Chronic alcoholics have thiamine deficiency and 4th step is affected in them. So also know first what 4th step is, what is its enzyme, what are its vitamin, then relate clinically to chronic alcoholics, thiamine deficiency. What happens to PDH there? Chronic alcoholics, thiamine deficiency. Is PDH fully functional? Is PDH fully functional? No. So connect them. Starting molecule of TCA cycle is not pyruvate, it's acetyl-CoA. Let's do this and know what steps you need to know. First step is rate limiting. Starting molecule is what? Starting molecule is acetyl-CoA. Is it in the matrix? Is this cycle in the matrix then cytosol? Yes. So now citrate synthase is the rate limiting step. Please know that. Aconitase can be inhibited by rat poison. Isocitrate dehydrogenase is the second rate limiting step. It is associated with vitamin niacin, which is B3. Alpha ketoglutarate dehydrogenase is the third rate limiting step. It's associated with how many vitamins? Alpha ketoglutarate dehydrogenase is associated with how many vitamins? Not 2, 5. Thiamine, same as PDH, very good, 5. Thiamine, lipoate, coenzyme A, NAD, FAD. Alpha ketoglutarate dehydrogenase vitamins are same as PDH, so I'm telling you importance of each step. Alpha ketoglutarate dehydrogenase vitamins are same as PDH, yes or no? Are they same as PDH? Yes. This is substrate level phosphorylation. This step is associated with FAD, not NAD. Different vitamin. This step is not associated with any vitamin. This step is associated with niacin vitamin. So bring in your vitamins, bring in your rate limiting step. Also, NAD, wherever there's NAD, 1, let's see wherever there's NAD, 1, 2, and 3, they will be linked to what phosphorylation? Oxidative or substrate level phosphorylation. Wherever there's NAD, oxidative phosphorylation. Wherever there is FADH2, that will be linked to NADH and FADH2. Steps will be linked to oxidative phosphorylation. So how do you know it's an oxidative phosphorylation steps? That step should either produce NADH or FADH2. Is this oxidative phosphorylation step? Look at my laser pointer. Is this an oxidative phosphorylation step? No. It's a substrate level phosphorylation. I explained you very clearly. Also, please, arsenic poisoning, Dr. Binstock has mentioned. Where is arsenic poisoning? Isocitrate dehydrogenase or alpha ketoglutarate dehydrogenase? Yes, three rate-limiting steps are citrate synthase, isocitrate dehydrogenase, alpha-ketoglutarate dehydrogenase. So which one, arsenic poisoning should affect isocitrate or alpha-ketoglutarate dehydrogenase? Arsenic poisoning. Isocitrate or alpha-ketoglutarate dehydrogenase? Arsenic. Which one? Arsenic have affinity to which component? Lipoic acid. So who has lipoic acid? Isocitrate or alpha-ketoglutarate? Alpha-ketoglutarate dehydrogenase. So arsenic poisoning should inhibit alpha-ketoglutarate dehydrogenase. I am bringing your attention that every step is specific, related to specific vitamin, specific process, oxidative substrate, specific toxins. So please pay attention on them. Did you count 38? 8 aerobic, 6 PDH step, and 24 TCA cycle. Did you count 38? Did you count 38? Yes. That was when, now remember, why did you need shuttles? You need shuttle to move the NADH of glycolysis. NADH of glycolysis are in mitochondria or cytosol? NADH of glycolysis are in mitochondria or cytosol? NADH, they are in the cytosol. For that, you need shuttle. If you use glycerophosphate shuttle, you lose ATP. If you use malate shuttle for them, the ATP is 38. That's the difference. So remember, these shuttles are to move the NADH of glycolysis, right? Also, please don't forget to do integration. Don't do mega integration, but little integration of all your substrate linked to NAD will go to complex 1 or 2. All your substrate linked to NAD. Give me the substrate, give me the enzymes linked to NAD. Please give me the enzymes linked to NAD. Enzymes linked to NAD? Just give me any enzyme linked to NAD. Can you name them, please? Enzymes linked to NAD. Anyone? Malate dehydrogenase, pyruvate dehydrogenase, isocitrate dehydrogenase, alpha-ketoglutarate dehydrogenase. Very good. And what are the enzymes linked to FAD? Any one name? Enzymes linked to FAD? Succinate dehydrogenase. That is why we did succinate dehydrogenase. That's why we did that interactive session question, that succinate dehydrogenase and FADH2 will go to complex 2. So don't forget to do that little integration that between ETC and TCA cycle. Now let's do PDH deficiency, because TCA cycle is also about PDH deficiency. Also, please, TCA cycle is amphibolic in nature. And that means some intermediates of TCA cycle are involved in anabolism. One big one is citrate. Since citrate is involved in anabolism, that is why it's always slowing down what? Is citrate slowing down glycolysis or activating glycolysis? When citrate is high, does it slow down glycolysis or activate glycolysis? High citrate slows down. Let's do PDH deficiency. Everything is around the step, whether glycogen storage diseases, pyruvate kinase deficiency. What happens to intermediates above the block in PDH deficiency, high or low? Intermediates above the block. What happens to them? High. So lactic acidosis, high alanine should be in PDH newborn. And intermediates behind the block, they should be, and intermediates behind the block should be low. So in a PDH deficient newborn, more common is PDH1 deficiency. Remember, PDH is a multi-enzyme complex, E1, E2, E3. E1 is associated with thymine. So PDH E1 deficiency is common, but in PDH deficiency in general, what will happen to TCA cycle? Active or slow down? TCA cycle, PDH deficiency, active or slow down? Slow down. So how will a PDH deficient newborn present as? Everything is around the step, hypotonia. So if you see hypotonia because of low ATP, lactic acidosis, high alanine, you are thinking of PDH deficiency. Also in PDH deficiency, because is this pathway deficient? Is this step deficient in PDH? Is 4-step deficient in PDH? So 3-step is turned on, and that's why they may have hyperglycemia. Please don't forget to relate step 3 to which pathway? Step 3 is which pathway, please? Step 3 is which pathway? Gluconeogenesis. Don't flip-flop that. 3 is gluconeogenesis. Enzyme? Enzyme quickly. Everything looks good, same, pyruvate, pyruvate. But what's the enzyme at 3? Enzyme at 3. 3-step, pyruvate, pyruvate. This is PDH for 3, pyruvate carboxylase, vitamin. Vitamin at 3-step. Biotin, vitamin at 4-step. Vitamin at 4-step. Multiple vitamin, but thymine, right? PDH. Multiple vitamins. So bring in your, sorry, what's happening here? The last slide now. Everybody can see that. Great. Now let's go to the last slide. Lactic acidosis. Since cardiac muscles are not adapted for aerobic glycolysis, myocardial infarction, lactic acidosis. Do chronic alcoholics have lactic acidosis? Please know your pH range and glucose. pH is 7.35 to 7.45. Note them down, please. And glucose is 90 milligrams and 5 millimoles. That will help you, right? And rapid dividing cells will have lactic acidosis. You use them as PAT scan, remember? PDH deficiency, do you have lactic acidosis? So see, there are a lot of differential of lactic acidosis. Do them and why? Get the answer why. If you have any questions, let me know. Please, the exam review will be Monday for glycolysis and TCA. I will also bring Dr. Binstock's slide. I think I wanted to do this like a recap. Wish you good luck. If you have questions, you can stay.